This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 55, a look at what is exciting about Ansys 2020 R1 and an update on the world of Ansys. Greetings from the Doubletree Inn in Tucson, Arizona. I'm in town for the 2020 Arizona Photonics Day, and it's also, turns out, the Gem Show week in Tucson. That's when thousands, hundreds of thousands of people actually, who like rocks, come to this beautiful city to, well, look at rocks. It's a big deal if you're in the gem and kind of shiny stone world. People come from all over the world for this show. Unfortunately, the AZ Photonics Day is based upon, it's always the week before the big photonics show in San Francisco. So we can't really change the time, so we have to share a crowded space. There's not a lot of hotel rooms open during Gem Week in Tucson. So I'm enjoying my 50s retro stay. If you've never lived in the Southwest, this is a very typical 1950s kind of motel with the pool in the middle and entry, glass in the front, glass in the back, and a entry through a sliding glass door off to a balcony and brick walls and lots of Southwestern colors. It's actually kind of nice. It's kind of retro. By the way, I'm Eric Miller. I'm the co-owner of PADT and your host for these podcasts. A little bit about me. I've been an Ansys user since 1986 when I graduated from college and moved to Phoenix to work at a company called Garrett Turbine Engine Company, which is now Honeywell. And on my second day, I was introduced to a piece of software called Ansys, and it's been a great relationship ever since. And enjoy doing these podcasts and talking about what's new and exciting in the world of Ansys. This episode itself will include a discussion on what our support team likes about Ansys 2020 R1 and a look at Ansys news. And I'll throw in there actually some observations from the Ansys sales kickoff, which was last week and just got back from. And speaking of that, I apologize for this podcast being late. We were in Orlando, the whole sales team and a couple engineers and myself and my co-owner Ward. And we were there for the sales kickoff, and we thought we'd record some interviews while we were there, but it just never came together where the right people were at the right place at the right time. It's a very busy couple of days with lots of meetings and training and talking to people and networking. So we're a little bit behind. We're catching up now, and that everyone is back, and had a talk this morning, and then I drove down to Tucson, and we're recording the rest of it now here in the hotel room. So speaking of the interview, Ansys just put out the 2020 release called R1. It's the first of the year, and it's the full suite of products. It's not just one or two, it's all of them. And we spent some time talking about what we like and what we think people should check out because it'll make them more efficient or give them new capability. So take a listen to what our team had to say. All right. Well, I want to welcome everybody to another discussion about another new version of Ansys. Be careful of what you wish for. We always wanted faster and more releases, more feature-packed releases of Ansys software, and they've delivered on that. And so we're here today talking about Ansys 2020 R1. And with me, I've got Josh Stout, who's new to the podcast, Sina Gohds, Ted Harris, and Tom Chadwick. So Josh, one of the other traditions we have is you got to introduce yourself and tell us how you got into the world of Ansys. So tell us about your background and how you ended up being an Ansys user.
Oh boy. All right. Well, I guess my first exposure to Ansys really was as an intern for you guys 7 years ago. I was a student mechanical engineering at Arizona State. Since then, I moved on to graduate school in Illinois, and I've moved back to Arizona just in the last 6 months. So here I am back at PADT, working with Ansys again. So it's been exciting.
And you're a second generation Ansys user, is that correct?
Yeah, I guess you could say that. My dad was also a mechanical engineer who works with mechanical pretty extensively.
Yeah, he's been a long time customer of ours. So, and what I would call a power user. So you've got a little bit of genetic head start there, which is good. Sina, why don't you introduce yourself and tell us what you do here at PADT?
Hey everyone, I'm Sina Gohds. I'm a senior application engineer, CFE application engineer here at PADT. And again, my background is a multi-phase and external fluid flows, using Fluent probably for 10, 12 years now.
Great. Has it been that long now? Wow, that's great. Time flies. Ted.
So my name is Ted Harris, and I manage what we call our simulation support group here at PADT. So very long time Ansys user. Started using Ansys on day 2 of my first job right out of college a few decades ago.
Yeah. And Tom.
My name is Tom Chadwick. I'm the senior CFD application engineer here at PADT as well. I have probably not quite as long as Ted experience with Ansys. I've been using CFD for around 30 years now, but didn't get exposed to Ansys until the mid-90s. But longtime user of multiple CFD codes for various applications, everything from hypersonic flow to lithium-ion battery cooling.
Mm-hmm. Both very hot topics right now, by the way, but both figuratively and literally.
Yes.
Now that I think about it. Okay, so like I said, we're. By the way, my name's. I always forget to introduce myself, but sometimes people skip to just the interview. I'm Eric Miller. I'm one of the owners here at PADT, and I've been using Ansys for a year longer than Ted. I started a year before he did at what's now Honeywell, and here at PADT, I do a lot of stuff, including overseeing our consulting group as well as marketing and HR and facilities. So welcome everybody to our discussion. And who wants to be first to say what your favorite thing is in 2020 R1?
I guess I can start.
Go ahead.
So Fluent specifically, it's an effort that Ansys started beginning of last year, actually, to give users a new user experience. And
Yes.
For that purpose, they introduced different workflows, meshing workflows. So the idea is to have new users, or not necessarily advanced users, to easily navigate through the software, get decent results without necessarily having decent experience. And less, clicks, less setup time, and in continuing that effort, and the 2020 R1, they added some cosmetic, a new look. Basically, it's just software. They've added new rendering effects, which is now software really looks really modern and updated, basically software. And some colors, contours, plots, they all look new. They have consolidated many menus and pages. Probably the most one is the lunch page or window. They've consolidated, so it's a very new look and a very, again, more efficient way to use Fluent. If you've used it before, now all the options are narrowed down, again consolidated to probably one page, or very accessible. And again, the look is very new and fresh.
Mm-hmm. Yeah, I think I've been hearing from a lot of folks that's really popular, and we have competitive codes that may have a newer GUI, and what we hear is, I want the capabilities in Fluent, but I want a more modern user interface. So it's great that that's happening. Very excited about that. How about anybody have anything on the mechanical side?
Sure, I'll go ahead and talk about that. So number one on my list is what I'm calling Granta Selector in Workbench. So Granta Selector, for those not aware, Granta was a materials, we'll call it materials management company that Ansys acquired recently. And so we're seeing the integration of those tools at a higher level within the existing Ansys products. And so Granta Selector is a tool that gives you not just access to what I'll call zillions of different materials, but it also has, advanced materials in there, allows us to make some choices, some intelligent choices between different materials based on cost and things like that. And what's new is Granta Selector is now in Workbench, and so you can add it as a block within the project schematic, and then open it up and browse or search on a material of choice, or look at several different materials and make a decision on which one you want to use in your downstream simulation. And then it's as simple as right-clicking and exporting to engineering data. And then we're in the standard Workbench workflow, and we can link that engineering data block to any downstream simulation where we want to use the materials that we've identified in Granta Selector.
Yeah, I think Granta is going to be a major tool. I think we've all of us who have been doing simulation for a while have always wanted a better way to do material properties, and just every time we go to an Excel spreadsheet to grab properties and paste them into engineering data, we know there's got to be a better way, and now there is. So that is a fantastic tool, and I'll follow on that with another Granta product, which is brand new. It's called Granta MI Pro. It's not really part of mechanical. It's a standalone tool. But a Granta MI is a tool used to it's kind of like data management for your material data. And Pro is kind of a shrink wrapped version of that doesn't need any customization, or if you're not an enterprise where you don't need all this special stuff. So you kind of can use it out of the box to be your repository for your material data. And again, this is kind of Ansys filling in those gaps, right? Companies are rolling their own material data management tools, or they're using Excel. And so Granta MI Pro is going to be fantastic. And we'll definitely be talking about that as well as Granta for simulation or mechanical. Forget what the full name of it is. I think that's something that everybody should have, is what Ted was just talking about. It's going to be awesome.
I see that Granta MI is an option in Workbench 2020 R1 as well.
Correct. So you can go all the way up to the high-end enterprise. If you work at an enterprise, in fact, many of you listening may work for a large company that's been a Granta customer before the acquisition. So make sure you reach out to your material science folks and make sure they're using the Ansys connection tools so that you can get to the material database directly from within our environment.
We've been training and supporting customers in Ansys mechanical simulations in the last 25 years, really, and not quite that many for me at PADT, but certainly over 20. And one of the biggest pain points has been, where do I get my material properties?
Yeah.
And customers need to perform a simulation. That can be the hardest challenge, is obtaining the material properties they need. And Ansys has really taken some big steps in the last year or so to eliminate that pain point, and Granta is the key.
And we're going to come back. We talked to the founder of Granta last year, and we're going to do another podcast on Granta. We're going to let kind of the waters settle with these new tools, and then bring them back in to talk more about how people should be using it. So what else? Who else has got, now that we've sung the praises of Granta, what else does somebody have?
Well, as far as the Fluent tool, I know Sina mentioned some of the improvements that they've done, but in specific details, they've added a lot of more capability into the watertight meshing tool. When it started, it had some limitations just based upon what you could do. For instance, you could only apply one boundary layer inflation setting for the entire model, but now you can tag individual labels or zones and apply settings to each zone, so you can have multiple boundary layer controls, which is really helpful for certain problems where you might have a small feature detail that you want to wrap inflation around, but you don't need it for the rest of the model.
Right.
In addition, there was a limitation at the beginning that you couldn't handle periodic boundaries. And now they've added in the capability to handle periodic boundaries in the watertight meshing. And that's a big deal for turbomachinery applications specifically.
Huge. Spinny things. Yep. Meshing has been a consistently growing and improving area, and I'm really excited about it. How about you, Josh? You're a relatively new user. What are you excited about?
Well, there are a couple things that I've written down. I've done a lot of looking through IcePack, specifically the electronic desktop version recently. My impression is that in this 2020 R1, they've done a lot of reconciling between the electronic desktop and the standalone versions. So really before, the AEDT version was really kind of falling behind as far as capability goes.
Right.
But they've done a lot to catch up with the standalone at this point. So now you can do the full transient solutions is probably the biggest thing. But they've also moved over a lot of the macros that were in the standalone.
Oh, that's big. Yeah, that's huge. Yeah.
Yeah, so a lot of geometry creation stuff. There's also the divergence debug tool, which is pretty useful. And that's mostly what I have for IcePack. I also have I have some comments on Discovery Live too.
Let's go there. Yeah, I think there's a lot in Discovery Live. What have you got for that?
I think probably the most exciting thing about that is just advancements on the topology optimization. So before it had been only for structural, really looking at stiffness. You could do some basic definitions like you want to reduce the total volume of a solid by a certain amount. But there are more controls for that now that I think are more oriented towards actually manufacturing, or being able to manufacture the final shape.
Yeah. It's if you haven't used Discovery Live or seen a video of it for topological optimization, because Discovery Live is such a fast solver, it is really quick on coming up with these shapes. I mean, it's not instantaneous, but like in 10 or 15 minutes, it's optimized the geometry fairly well.
For those that came by the PADT booth at the ASME Turbo Expo last summer in Phoenix, braved the heat, we had a video going that showed a topology optimization performed in Discovery Live. We compressed it down to about a 5-minute video, but the actual topology optimization study took about 20 minutes.
Nice. To
start with a block of material and end up with something like an engine mount that was a nice reduction in mass, as well as a workable from a force and stress standpoint.
Yeah, I think the other thing I'll add for Discovery Live that I remember seeing was that we can do kind of thinner. It struggled sometimes with really thin geometries, the way the algorithm worked, and that's been kind of healed literally. They can handle thinner geometries now, so that's a big improvement. That was limiting the kinds of problems you could solve with it, so that's there. And they also introduced a steady state solver on the fluid side, which I think was important. Let's make it a transient solver because everything's transient in fluids, and then we listen to the users who are saying, sometimes I just want a static solution. So I'd rather be able to get a static solution and change my geometry and see what the steady state is than let it watch it. It's really cool to watch it reach steady state, but I don't need to watch it reach steady state. It doesn't add value to me. So that was really cool. I'm really excited about that.
And actually, kind of on that note, it's a little bit funny. They also added a time averaging for the transient solutions.
Oh, I didn't know that. Okay.
Yeah, it's kind of another option there.
So again, driving you to make design decisions up front really quickly. How about anybody have anything to talk about on the structure side? I've got a list if you don't.
Well, I have one for the mechanical that really applies to everybody that uses mechanical, and that is an integrated progress bar. So when you're solving, when you're meshing, so it used to be that a little window popped up that showed the progress and that had the stop button. That little window now no longer shows up by default. However, right at the bottom of the window, there's a progress graph and there's a pause button there. So it doesn't take up as much space. It's not a separate window that you might accidentally click on and close. However, if you still want to see the old-fashioned, old-fashioned, it's kind of a strange thing to say, but the traditional pop-up window, all you have to do is click on the new progress bar and the older appearance window will pop up, and that has the controls to stop or whatever the appropriate condition might be based on what you're doing. So that, to me, that's nice because it's integrated within the current window. It takes up less space. And like I said, you don't have to worry about accidentally clicking on it. Not that I've done that, but I've been fearful.
I've had friends that have done that. Yeah, friends. Yeah. Also, one of the things that I got excited about on the structural side was just a lot more for doing beams and shells. So kind of the streamlining that workflow to do cross sections and line bodies and reinforcements, and it just seems like modeling large structures. There's a lot of work going into that. Both on the solver side as well, and when we do our detailed dive into mechanical, we'll definitely talk more about that. But I'm really excited for people that make rockets and bridges and cars. There's just a lot of new enhancements that are going to make that easier.
Yeah. And there have been steady enhancements in bringing in external models as well, with the ability to bring in more options in the types of elements and cross sections and things like that.
Yeah. So just making that much more capable. What else?
So we don't ignore CFX. I just wanted to say that some of the things they've done in CFX, they continue to make improvements to the harmonic analysis capability for blades. In addition, they've been doing a lot of work on the ability to generate operating maps, which is a really nice feature if you're doing a blade design and you want to find out what the performance map of the blade is. You can now give it a whole series of mass flow rates and speeds, and it will generate all the performance results across that entire map and generate the map for you.
Very handy. Somebody here needs to write a way to get that into Flownex.
Yeah. And the other thing that they've done is there's been an issue before about modeling film cooling on blades. And there was a lot of back and forth within Ansys about whether they wanted to actually model the individual holes, and they decided that was too mesh intensive to do. So they've added in the capability to simply define physical locations on the blade, define the flow rate and the size of the hole, and basically it inserts like a source point at the location, so you can model the cooling flow coming out of the blade without having to go through the effort of generating a detailed mesh of the whole blade surface and all the little holes. So it allows you to move. The really nice thing about it is it allows you to move the holes around and adjust the cooling flow rates to see what its effect is without having to go generate a whole new mesh.
So for those of you who live in the world of turbomachinery, turbine CFD design, this is a feature that we've been asking for a very long time. I'm very excited to see that that's coming out. That's a biggie. That's huge.
Yeah.
There a lot of companies will keep one or two copies of other codes, older codes that do that just for that reason. So good.
Yep.
We're replacing Excel, we're replacing competitors. Good stuff. Sina, you got anything else?
Yeah, and I think probably 99% of the CFD users deal with turbulence and so turbulent flows. And for new or intermediate users, kind of might be complicated what model to use. They have improved. There's some improvements in that area. There's a new default for a viscous model. Basically, the software now uses a K omega SST, which is generally more accurate than the previous default is K epsilon. And then they also introduced a new hybrid RANS alias models called SBES. So in general, if turbulence was an issue before or kind of a challenge in your simulations, it might be some improvements, and you might get better results if you try it with a new version, basically.
That's big. I'm going to go totally off the topic of R1. At the Ansys kickoff meeting, I met a company that's using AI to do predictive turbulence modeling. I'm going to try and get them to come on so you guys can grill them. But I thought that was the coolest. That was the coolest application. So, basically it figures out what your turbulence needs to be using AI. I don't quite understand it, so that's off topic. But it has the buzzword AI and big data in it, so therefore it must be good. But I'm going to try and get them on the podcast because I thought that was fascinating.
That's cool.
Okay, one more short thing around the table. Ted, really quick, anything else? Okay,
well, I have one on topology optimization. So we've talked a lot about topology optimization over the last few years. The rise of additive manufacturing has really allowed us to leverage what topology optimization can do for us. So it's using the physics-based optimization approach to, in most instances, remove material while preserving stiffness based on applied loads and constraints and things like that. And so what I see as a really useful enhancement in 2020 R1 is in regards to the validation step. So the workflow is we start with maybe an existing design or maybe just a blob of material, right, where we apply some appropriate loads and constraints. And our first step is we solve typically a static structural simulation. There are ability to do modal and thermal as well, but static structural is probably the heavy hitter. Yeah. And then we perform our topology optimization where we're providing maybe some manufacturing constraints and some guidelines on amount of material to remove, et cetera. And then once that step is done, the final step is what we call the validation step. And that's where we're taking this optimized shape, which may be a very organic looking shape, and we're resolving it for appropriate boundary conditions. So loads and constraints that our structure is going to experience in the real world. And so what's new in 2020 R1 is that the loads from that static structural step are now automatically mapped onto the optimized shape in the design validation step. So it used to be we had to kind of jump through some hoops to get our loads on there, maybe apply some node-based constraints and forces. And now we don't need to do that because the loads are mapped automatically. Now, having gone through it a few times, I can say that you have to follow the steps exactly that are described in the help for topology optimization in order for that to work. I found that if I deviate from the steps, it doesn't automatically map the loads. But as long as you follow the steps in the documentation, it does work. And so that's going to be a tremendous time saver for people doing topology optimization, and really just shows the level of effort Ansys Inc. is putting into the topology optimization, additive manufacturing activities.
Yeah, we haven't even scratched the surface on additive. We'll go around the table, and I'm going to come back and mention a couple things there. Next on my list is Josh. What do you think? Anything else you want to add?
Yeah, so I guess the last thing on my list is back to Discovery Live. So, of course, we all know it's a great tool for initial design work and all that. But if you're trying to go through and validate your design, you need to run it into something a little bit more thorough. That's much easier to do now that they've added an export to mechanical option. So it will take all of your geometry and materials, simulations that you've run in Discovery Live, take boundary conditions, loads. It'll import or export all of that for you directly. So that's really I haven't tried it yet, but at least in theory, that's a huge step as far as making it easier to port over and save a lot of time.
For sure. Yeah, we have to try that out. Definitely. Tom?
Let's see. There's been some nice changes in Fluent on the transition of flows from what they call a volume of fluid, where you're dealing with, a liquid, a giant glob of liquid like a tank of water.
Okay.
To DPM simulation. So it automatically now handles the transition between that volume of fluid and say you've got a wave being generated in the liquid tank, and as the wave splashes against a wall, the water breaks up into droplets.
Oh, okay.
So it now handles that transition much better from a solid volume to individual droplets. And that has all kinds of applications, from sloshing liquids to fuel sprays to cooling sprays, all kinds of, painting, anything like that, where you're dealing with a liquid region breaking up into small droplets.
Sneezing. Everybody's got the virus I got virus on the brain. Virus spreading on the grain. And Sina, right? Last one.
Yeah. So again, I just want to mention some keywords if you're dealing with, or the application basically is what you do. Just to be aware of some improvements in Fluent. Radiation has got some improvements. Acoustics has got some improvements. Combustion, if you deal with non-premixed or premixed, there are now FGM final rate with some enhancement that I suggest to try. And if you have small particles, and before might have challenge to track them, there are some improvements there. So just to mention some keywords, if again it applies to you, definitely check out the new release.
Right. And then in the additive space, I'll add additive prep, which is a tool for kind of getting ready for running your model. Has added some stuff, and it now supports both SLM and EOS. It supported SLM machines in the previous build, now EOS machines at 2020 R1. We can now you can change your laser parameters and things like that from within the tool. Got some more accurate ways to model strain and stress, and plasticity as well. And we've validated for the aluminum alloy, aluminum Si10Mg, which I think is a pretty common one. And everything's faster and more accurate across the board. So definitely take a look at. There's a bunch of little ones in there. We'll cover those when we talk about that specifically. But if you haven't looked at any of these tools we've talked about today in a while, there's been a lot of improvements. I also want to apologize to all of you who are electromagnetics users. Our electromagnetics team is swamped, and we're unable to make the podcast. And when after this interview, when I talk, I'm going to talk about why we're hiring more people in that area. So please let your friends know, because we need help. We're busy with electromagnetics.
We'll get them on a podcast in the near future.
Yeah. We're going to cover this topic specifically, electromagnetics specifically. So that's it. I think we've gone longer than I thought we would, which is always a good thing. It means we were interesting to ourselves, at least. Thank you all for taking the time to talk, and we look forward to diving deep into each of these through the next couple months. Thanks a lot.
Sounds good.
Thank you.
Yeah.
Bye-bye. As always, when we do these updates, I recommend you read the release notes for whichever Ansys product you use. If you go to the help, there's always release notes, and that's really a really good technical summary of what's new and different in each piece of software. And if you've not used an Ansys product before that we talked about, or you haven't used it in a while, or maybe last time you checked it out, it didn't have the capabilities that you needed. One of the things to take away from our discussion is we keep adding. Ansys development just keeps adding so many capabilities so fast. The pace and quality of enhancements keeps improving. So it may be time to revisit some of those tools you haven't used in a while or you haven't looked at in a while. Normally, this is where we throw a commercial in, but we're still working on getting some better commercials. Till then, please consider PADT, a little commercial for us, as your Ansys supplier. If you're in the southwestern U.S., if you're anywhere between Texas and California, including Texas and California, give us a call. We'd love to be your support provider. And if you're not, or if you're happy with your current supplier, definitely consider us for consulting, doing simulation work with Ansys products, as well as customization. We do a lot of work about that. We'll have to get some of our folks on a podcast to talk about that, but we write vertical apps and custom workflows and added functionality for folks, like new user materials or maybe a new user interface capability to the Ansys products. That's a large part of our business. And we're not just good at Ansys, we're also do a lot with additive manufacturing, 3D printing, and product development. We have a whole product development team. So please do give us a try. We love what we do, and our customers tell us that we're good at it. So we'd love to give you a quote and help you out with whatever your engineering project is. So some thoughts on that sales kickoff. They call them SKOs. So what happens, and most companies that sell any kind of product will do this, is they get all the salespeople from around the world in a big hotel, and most of it is talking about who sold what, how to sell more, and how to what to know about new products and things. It's actually quite fun and very interesting from a sales standpoint, but it's also, because it's Ansys, we learn a lot from a technical standpoint. Most of what we talked about is confidential, but I can share 3 observations from my 4 days there. I wrote these down on my phone as I was taking a lift back to the airport at the end of the time I was there. Number one, and this has been going on for a while, but I think it's permeated the organization from a cultural standpoint. The whole organization has really accepted the fact that the way to grow sales is to deliver tools that make customers successful. It's not, how do I trick people into buying this tool? It's, how can I get development to add the features my customers want? How can I make sure my customers know that those features are there? How can I provide them training to make them capable? It's kind of a different mindset than when we go to other sales kickoffs. And it was everywhere. It was marketing people, it was finance people, it was sales people, it was the executive team. Everybody in the organization has kind of figured out that the way to sell things is to have a really, really good product. And of course, the people from development are standing in the back saying, "We told you so," because this has been their ethos for a long time. I don't know that Ansys has not felt that way, but it's really strong. And you see it in like new employees that get it really fast. So number 2, one of the things they do is they invite partners, people from the Ansys partner ecosystem. These are third-party hardware and software providers that may provide computers to run Ansys on, or their software tools that enhance or add to Ansys's capabilities. And it's growing quite large. It's a chance for us to go around and meet them and understand what their products do and how they fit into the Ansys world. And I spent quite a bit of time talking to a whole bunch of people. Hope to have some of them on the podcast. But we've always had a few good ones, but now we have a lot of good ones, whether it's computer hardware or I saw really cool code that models particles. Flonex, which of course is a product that PADT sells, was there. It's really cool, and I hope to have them on to talk more about how they fit into the Ansys ecosystem and how they may be able to plug some holes in your needs. And the third one, this was an observation from one of our new salespeople, is wow, everybody here is really smart. And this is sales kickoff, and we can make fun of salespeople all we want as engineers, but Ansys salespeople you can't really sell the tool if you're not a smart person, even if you don't have a technical background. And he was right. It is really a fun, smart, it's a good group of people. And I think that if you're just dealing with 1 or 2 salespeople, you may think yours are that way. But it's the whole organization, technical, engineering, marketing, the executive team, everybody that was there. Really, really smart people. So I really enjoy spending time with them. And I wish it was more than just once a year. It's a great event, especially meeting with the folks from Europe and Asia that come into town for this event and getting to know them. So enough about the sales kickoff. Let's go down and do some news. Ansys stock is doing fantastic. It continues to set new records. It was just a smidge under $281 a share today, which is the 29th of January. But by the end of the day, it settled down at $277.72. And they did announce that they'll be reporting their earnings for the whole year and for Q4 on February 26th. So stay tuned to see what that looks like and what they have to announce. It should be pretty good. In the world of Ansys news, pretty cool. Ansys has a new website. So check it out at www.ansys.com. It's really modern. I think it's a little bit easier to navigate. That Ansys is never going to solve the problem of they've got too much information to share. So it's a bit of an information overload, but with the number of products and modules within those products, there's really no way to make that easier to access than they have it now. It's a nice website. I like it. It's faster as well. Also in the news is they announced that sometime in January, early January, they had their 1 millionth download of the Ansys student version. So if you're an Ansys student, or if you're a student, college student, you can sign up and you can download a educational copy of Ansys. And they've had over 1 million of those downloaded. So that's a lot of college students using Ansys. That's fantastic news. They also announced every year they have a contest called the Hall of Fame where people can submit both on the company side and the academic side the models they worked on throughout the year. And they picked 3 winners for company and 3 winners for academic. The company winners, one was a simulation of asphalt drying. So it's phase change and heat transfer and stress and all sorts of cool stuff. It's a really neat model. Number 2 was the electromagnetic detector for internal cavities in copper. So this is using electromagnetic fields to induce a field into a chunk of metal and then measure how it reacts to see if there's a void there. I'm getting a little bit beyond my knowledge of things, but check that out. Even if you're not an electromagnetics user, it's pretty cool. And then the third is something that it's funny, we did at PADT, now probably 15 years ago, but it was really hard to do back then, and we didn't have the basic capabilities that we have now. It's a flutter tool. So flutter is, and this is particularly for a turbine engine, is when the natural frequency of a blade or like a fan blade is closely matched to the excitation of the air around it. So it kind of reinforces itself, and you get this flutter effect where you get this kind of forced vibration in the blade, and the blades can break if you move them too far. So we want to get rid of those. It also affects performance, and it's a difficult simulation. So these guys wrote a tool that simplifies the whole process and makes it really easy to calculate flutter in a turbo machinery. So if you do anything that spins and moves air, check that out. It's really cool. On the academic side, number 1 was a tool to find unexploded landmines. So that's very useful. Unfortunately, in many parts of the world, there's a lot of unexploded landmines. So this is a tool that uses electromagnetics to find those unexploded landmines. And then the other 2 winners were both in the heart simulation space. One was modeling an artificial heart ventricle, and the other was it was modeling the whole cardiovascular system, including the moving walls and all the valves and everything. So a really complicated multi-physics problem. So very cool stuff. Check those out. There's really cool pictures. If you want to find it, search for Ansys 2020 Hall of Fame competition winners, or just the Hall of Fame winners. And you'll find it, or you can go to the Ansys website, go to About Ansys menu, and then underneath that is the News Center, and it's like the 3rd or 4th article. Speaking of news, we don't have any for the PADT side of things, so nothing to say there. Ansys blog-wise, the 3 articles I recommend you reading. One is a look at doing complex 3D printing of a heat exchanger, and the heat exchanger's got some really gnarly geometry that was created with N topology and printed on a Velo 3D printer. And here at PADT, we're huge fans of both N topology and Velo 3D. Velo 3D allows you to do supportless 3D printing in metal, or near supportless. So it's perfect for these kind of complicated geometries with internal passages. So seeing Ansys N topology and Velo 3D working together is great. Number 2 that I liked was What Happens When Experts Silent Supersonic Flight. I'm kind of fascinated by supersonics. And it's a difficult simulation problem, so it's a neat one to look at. And then the last one is 3 technologies bring sci-fi to life at CES 2020. So Ansys had a huge booth at the Consumer Electronics Show in Las Vegas for 2020, and some of the guys walked around, and their observations on 3 ways the technology is doing some sci-fi type stuff that they saw. I need to get to that show one of these days. On the PADT blog, we have 2 articles from our high-frequency electromagnetics folks. First was Alec Gavaroff, and he had an article about reducing EMI with good signal integrity habits. So electromagnetic interference is what EMI stands for, and it's nasty, and you can use the Ansys HFSS products and some other ancillary products from the electromagnetic suite to identify and remove these EMI issues. And number 2 is also in the high frequency space. It's from our engineer, Sina Gohds, and it's defining antenna array excitation with nested if statements in HFSS. So this is something that we've seen a lot of our customers do with HFSS is doing these antenna arrays and how to model them and how to post-process them and everything. You can use these nested if statements to do some fancy stuff. So check that out if you're in that space. Upcoming events, we have a PADT webinar on mechanical updates for Ansys 2020 R1, and that's going to be tomorrow, January 30th. You probably are listening to this after the webinar, but all of our webinars are recorded and can be seen at a later date. So if you go to Bright Talk and look for PADT or look for Ansys, you can find all of our webinars, including this one, and listen to the recording. Other events going on, as I mentioned, I'm down here in Tucson for 2 days of talking about light and photonics and all that stuff. And that's going to start tomorrow morning, and 2 days at the Bio5 Institute at the University of Arizona. So great event. People from all around the world come for this. And I'm going to talk a little bit about Ansys and PADT, but mostly I'm going to be listening. The webinar I already talked about in February. We're going to have, and speaking of Tucson again, we're going to have our 2020 Tucson Ansys User Conference. That is going to be on February 5th down here at Brother John's Barbecue. So if you're an Ansys user in Tucson or Southern Arizona or Phoenix, you want to drive down, check that out. And then I and a bunch of other folks will be at the Pacific Design and Manufacturing Show, which is also the MD&M West show. We'll be there from the 11th through the 13th. Come visit our booth if you're in Southern California, and we'd love to talk to you and show you what we're doing. And then I'm going to be leaving a day early from that show and headed over to another conference called the Advanced Manufacturing Supply Chain Conference, which is over on Huntington Beach, which is just a short Lyft drive away from Anaheim. And I'm going to be talking about basically additive manufacturing and some advanced technology capabilities with additive and how it's changing the manufacturing industry. So if you're attending that conference or thinking about it, I'll be there. So stop by and say hi. In conclusion, I want to thank everybody for listening. Don't forget to subscribe to www.padtinc.com/opt-in to get our emails. Spread the word. We'd love to get more people listening to the podcast. And as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 55. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.